Hi, I'm Elliot Williams with Hackaday, and I'm here with Carl Bugeja, who has a bunch of integrated circuit PCB motors that he's printed out. So how did you get started doing this?
So my first idea was to try and make a smaller and a cheaper drone.
Yeah?
So that's how the idea came about. So normal brushless motors are a bit expensive to perhaps make them in a swarm. So that's this will be much cheaper.
Yeah.
And that's how I came about the idea.
Yeah, cool. And the thing I really like about those is that he's got the coils all wound up. I guess the coils are made up of the circuits on the printed circuit board. I didn't realize until seeing your presentation today that they were actually in 4 layers.
Okay.
And you've got a new one now that's six layers. Okay, first hold these things up for a sec because they're so tiny.
Okay, so
yeah, that's his big motor, and then that's the brand new one that's with a 6-layer board.
So they're both the same number of turns.
Yeah.
Almost. So basically, I was able to make the smaller of the area by making less turns per layer, since the extra 2 layers, obviously.
Yeah, that's really. Yeah, and how big are the tracks?
They're 4 mil. 4 mil width and clearance.
Yeah, so you can't make them by yourself, but and with 4 layers you can't anyway.
You cannot go smaller than that because then the price will explode.
Yeah, but these are still cheap enough.
Yeah.
In that size, they must be dirt cheap to get made by board houses. What do they have in them for bearings?
Yeah, they have a tiny bearing at the center, so 3mm bearing, and then just have a shaft. To connect the rotor with the PCB.
Yeah, oh great. And I heard in your talk that they get hot. What's up with that?
So this is getting to around 70 degrees Celsius.
Yeah.
So it's not that bad for a motor.
Oh, is that right? Yeah.
So basically, motors tend to get hot. So
yeah, I guess they do.
And
right?
at first I was expecting for this to get hotter.
Yeah.
But I mean 70 degrees Celsius, I'm quite happy with that.
Oh, okay, so. Super. Yeah. And just so that everyone knows, there's a ESC.
Yeah, so I designed an ESC for this. It has a whole sensor underneath the stator. So it basically, every quarter rotation the rotor makes, it will detect sort of the change in magnetic field.
Yeah.
So with that I'm able to get speed feedback and control
super.
speed.
Yeah, and you've been playing around with other kinds of PCB printed circuit, inductors, magnets, everything else. Show and tell.
So I have also made this flexible PCB actuator that sort of when you place a magnet underneath it and sort of pulse its input, it sort of flexes. I'm having I would like to use this for various kinds of robotic applications. One of them is a robotic fish.
Yeah.
So I'm hoping that it will turn out to be very cool.
Yeah, super. Yeah, and I saw you were doing speakers with them, and just basically you took this one idea and you're just running with it in all possible directions at once.
Really.
That sounds really fun.
Sort of a roller coaster of ideas. So.
Yeah, right? That's great. Well, thanks very much, and thanks for sharing it all with us.
Thanks a lot.